Okay, so what we're going to be doing in the first part of 1-6 is solving what we call compound inequalities. Think back to English. If you remember learning about compound sentences, remember what that is? It's two sentences that are joined together, usually by the word and, maybe or, but, we've got all those options. So compound inequalities are two inequalities that are joined together by either and or the word or. So we're going to focus on the and inequalities first. Here's how they work. So and inequalities are true if and only if both inequalities are true. Okay, so that's the important part with the and inequalities. So we think of this one as either the overlap or the intersection. You can use either of those words. So both inequalities are true. Okay, so let me give you just a quick look at what we're doing here. So let's start with this one. So just a very quick sketch. If x is greater than or equal to -4, remember we start with the 0, -4 would be down here, greater than or equal to. The or equal to part means that we have a shaded circle, and then the greater than part means that we shade off to the rights. All right, so that's our first inequality. Here's our second inequality. X is less than 3. So let's line this up, kind of keep it to the same scale. So line the 0 right up with the 0. And then the +3 would be right here. Again, keep it to scale, so like this distance should be a little bit longer than this distance. And then less than 3, just the less than means it's an open circle, and then the less than part means that we shade to the left. Okay, so like we wrote in this definition, if and only if both inequalities are true. So if we want to say x has to be greater than or equal to -4 and x has to be less than 3, there are plenty of numbers that fall into both of these categories. Here are all the numbers that fall into just this category. Here are all the numbers that fall into just this category. If we're looking for the and, we're looking for the overlap. So when is this one true and this one's also true? So kind of picture them lined right on top of each other. If you're looking for the overlap, it's this region right here, in between the -4 and the +3. So let's draw that. So everything in between the -4 and the +3, don't forget to leave the 0 on there. So the -4 is included because it's shaded here and it's shaded here. So that's part of the overlap. But then the +3 is not included because it is shaded in this one, but it's not shaded in this one. So the overlap would be in between these two numbers, but it doesn't include the 3. So there would be a closed circle on one end and an open circle on the other end. And then the other way that we can write this is a triple inequality that looks like this. First we write the -4, it's less than or equal to, and then you put the variable x in the middle, and then you say it's less than 3. So you can kind of look at it in two parts. You can say x is less than 3, and then if you look at the other side, read it backwards, x is greater than or equal to -4. So physically the way it's written, the x is in between the -4 and the +3, and that's what you see on the graph too. So that's what the and inequalities look like. So let's solve this one. So we've got a 3-piece inequality. Your end goal with the 3-piece inequalities is to get the variable by itself in the middle. So it's basically like the old rule of whatever you do to one side, you do to the other. With this one, whatever you do to the middle, you do to both ends. So here we have this subtraction of 2. So remember the opposite is to add. And so whatever you do to the middle, you do to both ends. Okay, so we've got 12. Keep the less than or equal to. That doesn't change. We have a 3y now left in the middle because these 2's canceled out, is less than, and then 19 plus 2, which is 21. Okay, so then again, we're trying to get our variable by itself in the middle. It's being multiplied by 3, so the opposite would be to divide by 3. And whatever you do to the middle, you do to both pieces. 12 divided by 3 is 4. The inequality does not change because I was dividing by a positive number, and that keeps them the same. So still less than or equal to. Now these cancel, so the y is by itself, and is less than 21 divided by 3 is 7. Okay, so solving it gives us this as our answer. And then to graph the solution set on a number line will look like this. So graph, here's the 0. And then the numbers that we talk about here are 4 and 7. So the 4 would be right here, 7 would be about right there. So this, remember the way this is written, this is shaded as all the numbers between -4 and 3. This is going to be all the numbers between 4 and 7. And then this, or equal to, tells you that the 4 is included. So we shade it. And then this less than tells you that the 7 is not included, so we leave it open. But it's saying that our variable y can be anything between 4 and 7, including 4, but not including 7. So then you shade in between. All right, so your graph would look something like that. So that's the and stuff. The or stuff, or compound inequalities, are true if one or the other is true. I guess we could say one or more inequalities is true. So they don't both have to be true with the or. One or the other or both. So let's look at this. So x is greater than or equal to 5. Here's the 0, so 5 would be right about here. Greater than or equal to 5, the or equal to means we have a closed circle. The greater than means we shade to the right. Less than negative 3. So here's the 0, so negative 3 would be right about here. Less than negative 3, just the less than means open circle, and it means shade to the left. Okay, so these are your two inequalities. You'll notice there's no overlap between them at all. So when we say or, it means either this one is true or this one is true, or potentially they could be both true. So one or the other or both. Basically what the or ones do is you just take them and you just combine them on the same number line. Whenever this one is true, whenever this one is true, you just draw them all together on the same number line. Okay, so you just copy this one down, put it on our final number line, and then just copy this one down onto our final number line. Okay, so again, just to clarify the difference, when we're talking about and, you only want to see where the two would overlap. Like if you were to lay them on top, picture if we did this in color, which I probably should have, say one was red, one was blue, the purple would be your answer. Whereas with the ors, whatever's on this one goes on the final number line, whatever's on this one goes on the final number line, they just all combine together, one or the other or both. Okay, so let's look at our or example. So solve this or this. Now this, I've had some sassy kids over the past that when they see the word or, they decide they only have to graph one or the other and they get to choose. That is not what the word or means mathematically. It means we solve them both, we put both the answers on the same number line. So here, these are just quick little one-step equations. We want to get the x by itself. So the opposite of adding 3 is to subtract 3, and we do it to both sides. So these cancel, we get the x alone. Keep the less than, because we haven't done anything to change the sign. And 2 minus 3 is negative 1. So that's 1. And then here, notice we have a negative x, so it's being multiplied by negative 1, so we divide both sides by negative 1. And then remember, when you divide both sides by a negative, you do flip the inequality symbol. So just the x is by itself now, and then this less than or equal to will flip to a greater than or equal to. And then negative 4 divided by negative 1 is a positive 4. So I'll squeeze the word or back in there. So our final answer, we're looking for either numbers that are less than negative 1 or greater than 4. And if you think about those sets, there's no overlap between them. So we just graph them both on a number line. So start with your 0. So first plot the less than negative 1. So here's negative 1. The less than symbol means we have an open circle and we shade to the left. Or greater than or equal to 4. So here's the 4. Greater than or equal to means we have a closed circle and we shade to the right. Okay, so that's what your final graph would look like.